Okay, this is our performance funnel study guide for a performance funnel coming up on Monday the 29th. Okay, so we're going to go back through some of the main things we've covered this semester. We started the beginning of the semester with electrostatics, where we're moving electrons through different what we call charging methods. Okay, so first we're going to talk about charging with friction. So let's say we've got two objects here. It looks like they've got a cloth and a ruler, and I guess that's a ruler, and we're rubbing them together. So that's what friction is. You just rub two objects together. So what do they have at the start? So with friction, both objects are going to be neutral. Remember, neutral means you have the same number of protons and electrons, okay, or pluses and minuses. And then when we rub them together, we're going to transfer some electrons. Okay, so one of these objects is going to gain some electrons, some is going to lose some electrons. Okay, so at the end, we're going to have one with what we call a positively charged, and one is going to be negatively charged. What that means is that one object loses electrons and one gains electrons. So the negatively charged object is going to pick up electrons. So it's going to have more electrons. So it's going to become negatively charged. And then the other object is going to lose electrons. So it's going to become positively charged. It's going to have less electrons. The total number of electrons between the two objects is the same, because remember, charge is conserved. You can't destroy or create charge. So let's put that total number of electrons stays the same. So it stays the same. You're just moving charges around. Okay, and that's kind of the theme of the different charging methods we talked about in electrostatics. We're not ever destroying or creating any electrons. We're just moving them around. Okay, so then let's talk about conduction. So here we've got our electroscope. Remember our handy little electroscope. It's got the conductor at the top, and then it's got these two leaves that hang down that tell us, if we've got a charge present. So with conduction, remember that one requires contact, and friction does too. But with conduction, we're going to touch a charged object to a neutral object. Okay. So objects have what charges at the start? Let's say this is negatively charged. Okay. And we could do this either way. Okay. I'm just picking that one as an example. So this one's negatively charged. And then my electroscope is going to start off neutral. Okay, so it's going to start off with the same number of positives and negatives throughout it. Okay, so at the start, one is charged and one, so this object, the rod, we'll call that a rod, and the electroscope is neutral. Okay, then we touch the negatively charged object to our electroscope. Okay, and what's going to happen when we touch them together is some of these extra electrons that are on this negatively charged rod, it's negatively charged because it's picked up electrons from somewhere before this. It got some extra electrons. Some of those electrons are going to move onto the electroscope. because we touch these together so they can physically transfer between the objects. Okay, so what we end up with is two objects that both have a negative charge. That's why these leaves go apart, because now these are like charges and they repel. Okay, so with conduction at the end, both objects have the same charge. And what happens is that the electrons move from the charged object to the neutral object. And this would work if this were positively charged too. It'd just be the other way around in terms of the movement, because if this now, say this has less electrons, this one's neutral, some of its electrons are going to go over to the positively charged object because opposites attract. And so we would end up with basically less electrons on both objects. Okay. Again, we're not losing or gaining electrons. They're just moving around between these two. But with conduction, it's really important to remember it requires contact. And in the end, both objects are going to have the same charge. So if you're starting with a negatively charged object that touches it, they're both going to be negatively charged. If you have a positively charged object, they're both going to be positively charged, because the electrons are going to move from one object to the other, depending on what the charge of this object is. Okay. Okay. And then we've got induction. That's our last one here that we're going to look at. Induction is no contact. So this is where we're bringing an object near another object. So let's say this is a positively charged object this time. So it lost electrons somewhere. Okay. My electroscope is still going to be neutral. And I've got, remember, this is called a grounding rod. Okay. So this is going to take away excess electrons. So at the start, so again, one is charged some way, and the electroscope is neutral. Then at the end, okay, so this is what happens at the end. These two aren't going to transfer any objects, okay, any electrons, because they don't actually touch each other. But when this is brought near the electroscope, it's going to cause a movement of charges in the electroscope, okay. So in the case of this one, where I've got a positively charged object, electrons are going to collect up here because they want to be near this positively charged object because they are attracted to it. So I'm going to get more electrons moving around, trying to be near this object. That's going to leave more positives down here, or less electrons really, down here in the leaves, and so they move apart. Now this one is grounded, so that's going to give these electrons a place to go. So they're going to collect up because they're trying to be near this positively charged object, and then they're going to go out the grounding rod, okay, down into the earth or whatever. That's where grounding rods typically send extra electrons. And so in the end, this one, notice this one hasn't changed at all, okay, because it didn't touch the electroscope. It's just hanging out near it. So what I end up with afterwards, okay, I've got some of my excess electrons have gone away. I'm going to end up with what's called polarization. Okay. So let's say at the end, I've still got one that's charged. And that's my original like charging rod or whatever that I brought near it. Okay. And one is polarized. And so what happens in polarization is charges separate. So charges separate into opposite types, I guess. So here, because this is positively charged, the negatively charged are going to want to come up to the top to be near it, leaving less negative charges in the bottom. So I've got a separation of charge here. And some of these electrons are going to go away through the grounding rod. Okay. But the remaining ones are going to collect up here. And then I'm going to have positively charged leaves down here because they have less electrons. So they're going to move apart because they repel. So polarization is where our charges separate. With induction, you end up with, it's kind of oppositely charged objects, okay, because you've got one that's going to be polarized and it's going to have the opposite charge of whatever this object is at the top because opposites attract, okay. So let's see if I can write a little bit of that here in this space. Oops, and I'm almost out of time on this video. I'm just going to write opposites attract to help us remember that. Okay, so that's our quick review over electrostatics. Next, circuits.